Hi everyone, myself Krish Aitukam, very warm welcome to all. And this is day 14 of Foundation AI series. So in this day, we're talking about little bit about vector operation. So as we know, we covered lots of topic about vector, and first is day 11 video and day 12 video is based on vector and such as vector scaling respectively. So but the today is the time for vector operation. So we are looking toward their why this particular vector operation is important, and so I will try to connect this all the particular example. So overall agenda for today is like the first we are looking toward the vector operation. So we discuss a little bit about cross and dot product, and a little bit about vector subtraction and vector addition and real world application. So at the end, as you know, like I will always try to just connect this all this mathematical concept, and math is abstract, but in real world example, if we connect this abstract knowledge to real world example too, that's making fun. So for understanding much better. So again, if this particular video is going to productive for you, and if you learn something from there, then it's my pleasure. So let's go. Let's come to the agenda number 1, and in this agenda we are talking about vector addition, vector subtraction, and how to actually add a two vector and how to subtract a vector. So I think like the two main way that I think you can add and subtract a vector. The first way is like algebraic method, and second one the like geometrical method. So I prefer to understand like geometrical method because of that this particular method visualize much better. So that's all about it. Okay, so in the case of the algebraic method, that you can like add the both vector. Like now suppose if you want to add the two vector a and b, so you add this both vector like in like component wise, like x axis of this both vector are added by x axis with x, y axis with y. So that's all about it. And second, if you want to subtract, you can do simultaneously, but this both kinds of things, like x-axis with x and bx with bx, the ai with ai and like ay with minus by. So simultaneously with like x and y axis, you can add and subtract. So that's the very easiest way to like component wise, you can say algebraic method, work in component wise subtraction, component wise addition. So that's all about it. And what are the graphical way to to just or like adding a vector or subtracting a vector. So the best way, like now suppose this x-axis and y-axis, this both vector are connected. If this both vector connected with a head or head, okay, now suppose head and tail, this is the head and this is the tail. Head to tail method. Now suppose some vector connected like this, head to tail. Now this is the tail of this particular vector, and this particular vector connected with this tail, you can find this you can add this particular vector. Now suppose this one a and this one is the b, so a plus b. So that's all about it, like graphical method that you can use this particular thing to just as a vector method. So that's all about it. Okay, and second part is like you can subtract this particular vector. Now suppose both vector are opposite in direction, so you can just you can subtract it in such way, like better way to visualize. Now this particular vector a and b, so you can subtract in such way like a minus b, something like, okay, that's how you can find the result. The graphical way to understand like the vector is the two way, like if the both vector have in a different direction, so you can subtract. Okay, so graphically way you can visualize this particular concept, like it's all about graphical way to you are not doing to manual to drawing each graph, but this is the graphical process is all about like better for visualization. So what's happened with two vector are added, so the two vector are added, because of that they both have in the same direction. Okay, and what happened with the two vectors are subtracted, two vectors are subtracted because of they have an opposite direction. So that's the entire architecture that we're looking for, and that's I think like that's how the particular architecture work. And entire goal of the graphical method is all about like something head to tail method is work to in adding the both vector, and if the both vector are connected with the tail to tail, then you can say this particular vector are subtracted and you got a resultant which is a subtracted value. Okay, so that's all about this is necessary why we are going to just discussing this vector. Again I will like memorize you why we are going to just like why we are going to discuss particular vector addition, vector subtraction. So it's all about like something finding relationship between data points. Just keep a patience. We discuss much about this particular concept, like how this particular concept work in their real world application. I will try to explain it. So let's come to their cross and dot product. Hey, let's come to the dot product, and this is the very fascinating topic if you want to understand. So let's come to understand. So when we're talking about dot product, so dot product is all about something we are calculating a magnitude, we are multiplying magnitude. So now suppose if the two vector, okay, you this represented like this, then you got a particular vector which is basically dot product, and dot product is all about like scalar multiplication. So you can say a scalar product, so that you got only for a scalar, so like magnitude only, not you are going to keep this particular product as a like vector. So it's all about, now suppose if you multiply this particular two vector are multiplying a and b, a dot b, then you got an a and b, so this particular value you have only for magnitude. Okay, so that's called the dot product. So when you multiplying a two vector, so there were two way to multiply a particular vector. The first way like multiplying a two vector in a way such way like you getting you on a scalar product, you are going to just find the scalar product only for magnitude, and second way is the vector product, like is all about like cross product. Cross product is all about something you can say like vectors, vector multiplication. So you got in a particular product as a vector also. So okay, so here is this is dot product is also called a scalar multiplication. So where we multiplying a two vector and we get an such as output as a only for magnitude of the both vector and combination of the product of the multiplication as a product as a like magnitude. So let's come to understand much better the first of all like calculation of the magnitude, and that's also called a scalar multiplication. So that's all about it. So there were two way, as we know, like this is a two way to understanding this particular vector and the calculating the both vector like scalar multiplication, like dot product. The first one is like this one is ax and bx, like simultaneously component wise, as we know, like both particular vector we can component wise. So we are doing such thing by component wise. Okay, so that the algebraic way to just like calculating a vector, okay, to doing multiplication. So we can multiply this both vector by like ax and bx as simultaneously like scalar product. So that's okay, both of them. Okay, so that's the component wise we can algebraic way, this is so called algebraic way to calculating a vector. Second one is like geometrical way, like a dot b. Geometrical way is all about like I'm not going to derivation for this particular concept, like ab cos theta. So this is a magnitude. Okay, you are multiplying both magnitude and you keep the value of the like theta. So now suppose like two vector are arranged in such way, like this is a theta angle, and now suppose theta is 90 and 10 0 180, that anything else. So you can put this particular value in there and you got the product of the both of them. So this is a geometrical way to calculating. So this particular formula is based on geometrical way. So okay, so that's either possible to find out their product of the two like scalar product, like dot product of the both vector. So that's all about it. Okay, and so let me analyze the first the behavior of the vector, like what is the visual behavior of the vector and how the particular, so it's properly depend on the theta. So if the theta change, then the two vector are parallel, two vector are perpendicular, two vector are opposite. How we know? We can decide this particular value at like two vector. We can visualize this particular vector. We can note down this particular by noticing, like you can notice the particular thing like something scalar product. Okay, so if this particular a scalar product is a particular positive value, okay, so then I think like the both vector are parallel to each other. Okay, so if the particular scalar product is really positive, then the both particular vector, both vector are like parallel to each other. Second thing, like you can say if the scalar product of the both vector will be zero, like if the particular thing is zero, then you can say like you can say the both vector are perpendicular to each other, and between the both vector I think like 90-degree theta angle. So that's all about it. And second thing, like if the theta is equal to 80-degree, like a scalar product like product is a negative, then you can think like the both vector have a opposite direction. So that's all about like opposite direction of the both vector is only possible when like both like a scalar product is like negative. Okay, so that's all about the magnitude and way to understand like visual behaviors of the vector. So this is the few like like this one is scalar product is positive and scalar product is 0, a scalar product is negative. That's how you can decide the particular visual behaviors of the particular uh, the particular cross product, like both vector. So that's a way to understand, like vector is performing very way, like they behaving differently. And by particular thing that you can understand, like if the positive, they can say parallel, and scalar product is 0, you can say like both vector are negative, like negative perpendicular to each other. And second thing, like you can, the scalar product is negative, then both vector are opposite in direction. So that's all about it. So in fact, we understand this particular both way to finding a scalar product. And overall, the conclusion here, like, is all about, like, a scalar product is all about finding a magnitude only. They are not dealing with such as a, like finding a direction. So if you multiplying both of vector, like by this particular method, then you get only for the product as a magnitude, not at going to you, that's you are not able to find out the direction, right, the direction of the particular vector. So that's all about it. And the few steps to know, like, this particular thing is helpful to understand the visual behavior of this particular vector. So that's all about it. So let's come to their cross product. Hey, let's come to the important topic. Like, this is the important one, and you should focus on. Because of that, like, let me discuss a particular topic. Like, this particular topic is like cross product, and in this particular topic, we are talking about like something cross product is all about. This is the important one, and again, I repeating this particular term as okay. So cross product is all about like something you are going to calculating multiplying two vector to getting a magnitude as well as direction also. So both kinds, like if you want to find the product as like magnitude and direction, then you are focused on the cross product. So that the particular operation which is based on multiplication of two vector to getting such as output as both product and like magnitude and direction also. So that's all about it. So this particular like cross product is also called that like vector product. This is basically they given a both quantity like vector and scalar also. Okay, so that's all about direction and magnitude of both of them. So first of all, to calculating like how this particular actually operations happen, what the mechanism behind the scene. So let me discuss the first. Like the first, we are going to discuss about geometric way, and geometric way is all about formula. So I'm not going to depth of the formula or how this particular formula is going to like. And the first one is like AB dot product. So AB dot product is all about like in this cross product, like AB, if you want to find out like AB sine theta. So AB sine theta is important. Like this particular thing is like AB sine theta. This formula, when you apply this particular formula, you got an output as a magnitude and such a direction also. So that's all about it. This is geometrical way to calculating a particular vector. But what's about algebraic way? It is too such a tricky to understand about algebraic way, but I will try to explain you. Okay, so algebraic way is to understanding vector is all about like something you want to just calculating this both vector in making such a grid. Okay, like just now suppose a1 ax ay az, but three directions. Like first you plot this particular according to their like I cap, j cap and k cap each value of the both product a and b, and then after ax ay and az. Okay, like plot this and bx. The first you try to cross product of the both, like first square this particular a1 ay and by, and it's cross product of the both, cross multiplication you should to do in this first square. Okay, just make a first square where you do this cross multiplication. Okay, I will try to explain you. Now suppose this is I cap, j cap and k cap. Okay, ax ay and az, bx and by and bz. Okay, the first you try to make some like first square, okay, and do cross multiplication. Okay, like bz ay and ay and az, like this thing ay and bz, and subtract this particular value. Okay, about something like az and ay, az and ay, az and by. Okay, so this is two way where you're going to just calculating a vector, and you are going to like subtracting the both value, like this both value you got a output as a one particular product of this both of them. So you got a value And after all, like combining this all this value as a, and you got the particular product as a, y, and similar like this thing. Okay, the first you make the first square where you're doing the cross multiplication like this, and again next next step is all about something, uh, it's all about something in this entire grid, like make cross multiplication from the corner by corner, like diagonally. Okay, and it's something like ax and bz and minus a2 bx. So that's how they look like this particular thing. And then after you try to make the other grid, okay, another square grid, and you multiply with this particular thing, like both four of them, like in their like multiplication to me. So that's the particular process where we're going to do. And the entire process is like something the what I'm trying to give you, like it's all about giving you idea to how this particular thing happened. And you are not going to do it manually with your hand to like understanding the model, the actually how the model want to learn this particular thing. And our next step is, the next agenda is all about like real world application. I will try to explain you, I promise you, I will try to explain you like all this particular confusing thing in such way easiest way. Okay, so okay, so if you got a product, okay, now suppose if you got a product, so what the way to, how can you know what is the, where is the direction of the particular thing? Now suppose, as we know, like the cross product is all about giving a particular product, like multiplying two vector, you got a magnitude and like something as well direction also. Then how can you know that where is the direction of the particular thing? So the way to know this is RHTR, that refer to right hand thumb rule, and RHTR stand for the right hand thumb rule and the short form I try to explain. In this case, like we are thumb, like we are keeping this particular index finger. Now suppose the this particular thing look like this is right hand from like your side, and this is a index finger, and you point this index finger to vector 1 and vector 2 middle finger, and this is the direction of the thumb of the coordinate of the coordinate, like where is the particular direction of the particular product of the vector. So where the particular vector lies, the product lies. So that's all about it. So that RSTR refer to right hand thumb rule, and it helps us to know that how the particular vector is where is the product like direction of the product. So it's all about it. So again, our last agenda is all about real world application, and I will try to explain you all this particular concept you should to know. And I will try to connect this all this entire tricky abstract concept with you from your side, like with their real world application to understand much better. So let's come to the agenda number 2. Hey, let's come to agenda number 2, and in this agenda we're talking about real world application. So finally, let me come to understand like all this particular concept that we are studying, and to tying this all the concept with real world application to understand much better. So before going to discussing about this particular concept, like real world application, that I would say you a brief introduction. Uh, like the few thing that you should to know before starting this like this real world application. So the cosine similarity. So cosine similarity, here I mention a cosine similarity because of that cosine similarity refer to something like finding relationship between two vectors, so two data points. So it shows like how your vector, where is the direction of vector and all this particular stuff similar between two data points. So it's all about it. Okay, so I will discuss particular thing cosine similarity in a depth in the next video, but today you can consider cosine similarity like finding a like the direction of the vector and finding relationship between two different vectors. So that's the basic thing. So so the first of all, in this our entire real world application, so we are going to just take one such a best example. Now suppose this is your location, location, this is your location, and this is the goal where you want to particular, you want to that goal location, like you where you want to go. Okay, now this is your home and this is your office. You want to go office. Okay, now suppose you want to go office. It's okay. So let me give a coordinate, like S is your like your home, and D is your goal, like this is the coordinate for goal. How actually GPS processing, and this is a best example like Google Map is basically processing how actually Google Map process all the data in such way like the finding the best route to go a particular office. Okay, how they take decision. So let's come to discuss. The first point is like this is your goal, this is your home, and this is your goal, like office. There were few routes we name this all this vector, like this vector as a ri vector ri. We considered all this particular vector. Let's suppose all this particular vector is ri vector. Okay, now suppose r1 vector, r2 vector, r3 vector, and this is your current location, and you want to try to visit this particular destination, like goal and office. Okay, so your destination is your office, and there were lots of vectors so that the particular location of the particular office. Okay, and we keep this all this particular value from 0 because of that, not from current location, because from model training. So as we know, like we need to keep this all the parameter as a 0. Okay, so because of that, removing a biases into model training during the model training, so that's the important part. And okay, so now suppose r1 r2 r3 vector, this all these three vector are actually showing the locations of the different routes, and the different routes considered as a different vector. Okay, so we do cross product to finding the closeness of the like office and home. Is it okay? So look, now come to understand. We are doing a dot product to finding a goal, your destination, your office. So now suppose r1, now suppose we taken a value like ri ith vector. Now suppose ith vector, let's consider ith vector as some root. Okay, we got from the giving such as doing calculation. Okay, finding a dot product, we get a magnitude, and that magnitude shows the distance between the home and town. So let me consider this ith root. Okay, we get. And second, so ith root shows that how much the particular vector is close to your home and your office. Okay, so home and office. So that's how. And second, after this finding the each of the ith vector, the dot product of the goal, and your location and your destination, you got like you are able to find out like a cosine similarity. And cosine similarity, if you got a value from the -1 to 1, if you got a 1, that your same direction, you are going for same direction. Okay, if their value is a 0, then it's going to perpendicular direction. Okay, you need to go perpendicular. So finding the root of direction, this you need to find out the cosine similarity. So the different data points, so it's all about it. So that's all. In fact, that right way to discuss like G and SP and show the closeness of the particular. So dot product here, the what we are using dot product, and we are going to use this dot product to finding the like exact location. This is a dot product, this is the goal, where we are finding this particular goal by giving a dot product like your current location and your destination, your office and goal, multiplying both vector. Okay, that's okay. Okay, uh, so if you find this particular thing, you are able to find out the cosine similarity, and cosine similarity shows that like what is the particular direction of the particular data. So cosine similarity shows that things. Okay, so okay, next, how this particular thing, like this is all about like where the cosine similarity used, like how the dot product is used to know. So here the use cases of dot product is to finding the closeness of the particular two vector. Okay, like your home and your office. So two vector are different. So if you want to find out each of vector like r1 r2 r3 to how much this all vector are close to each other, like you are going to giving to calculate with the particular thing, like uh, like uh, dot product. And after this, look, after this what happened, like you are going to just your model are going to making decision which route is best and what kind of parameter they can follow. So the parameter is all about creating a score of each route. Okay, so now support r1 r2 r3, and they create a score. This is a score, and this is a score, like how you decide the particular like vector, like particular, you can say particular route is like best route. The first thing, high cosine similarity. If the have a high cosine similarity, okay, so you can say this particular route is the best route. Okay, this parameter can be fulfilled. And shortest distance. So as we know, like we are always finding shortest distance for taking a less time. So shortest distance and minimum traffic, so this is a external parameter, but this three factor actually decide the best route. Okay, and after we multiplying this weight with all these three factor and getting a right output to training a model to which route is best, and they predict which route is best according to weight, adjusting a weight and biases, gradient, back propagation, all these particular thing happen inside it, and they know how they actually think is working on. So that's all about it. So that what the main goal of this particular real world application is all about. We are going to understand the what is the use cases of the vector operations in that case. So here the use cases, like overall, that in entire timeline that I want to explain you, okay, entire concept, like this real, like the main aim for understanding is like the dot product. Like dot product is all about using here is to finding cosine like different between two roots, or different between two vectors, like how much do both vectors are similar. Like now suppose r1, root 1 and root 2, how much the both vectors are similar, like how much both vectors are close to each other. So we need to find out this particular thing by using the dot product. Okay, so dot product help us to find out the which root is close to home from office, like office to home, no, home to office, sorry. So that's all about it. And again, that's the basic important part to looking toward the, like the goal product and sort product about this. And this kinds of the parameters, and this parameter is taken as a features, and each vector, like each parameter taken as each vector, okay, and multiplying with weight and to finding the best out route, okay, so predicting best route. So that's how the entire architecture. So the main goal of entire application, like I want try to explain you like all about like dot product. So dot product is used here to finding the closeness of the two different vector, like two different routes. Okay, so we finding a particular thing by uh, taking a dot product. A dot product is all about a scalar multiplication, where we are going to find out this all particular thing, like scalar multiplication help us to find out magnitude. So okay, so we are going to find out the magnitude of each vector, and then after we can analyze this particular route is the best or something else. So this step is all about creating such as a feature for this particular next step. Like next step is all about like when we are going to training a model to weight or biases anything else, then after your model want to learn, okay, to taking this feature and setting a weight according to it, then learn much better. So that's all about it. So overall, I try to explain you all again this particular topic is much clearly. And again, if this particular video is going to productive for you, and if you learn something from there, then it's my pleasure. And that's for my hard work, and that's for your patience. Okay, thanks for watching. See you soon.